Hello all. So we were talking about different methods of concentration, and in the last module we have already done with hydraulic washing and magnetic separation. Well, now it is time for us to talk about the most important concentration method, which is called as froth flotation, and it can be used precisely and only for sulfide ores. So let us understand what is a froth flotation. So in this, what we do is we will take a powdered sulfide ore, and to that we need to add oil as well as water. I repeat, we need to add oil as well as water. You should know that most of the sulfide ores are insoluble in water. Now, since they're insoluble in water, they will prefer to get wet by oil, whereas the gangue particles will prefer to get wet by water. So the principles of froth flotation is based on this. It is based on the preferential wettability. I repeat, it is based on the preferential wettability of the sulfide ores by oil and the gangue particles by water. And this froth flotation is carried out in a cell called as flotation cell, which looks like this. Now the next thing is we need to see the working of the flotation cell. So the very first thing that we need to do is we need to take a powdered or the pulverized sulfide ores, and we need to add water to it. Along with water, there are two other components that we need to add is collectors and froth stabilizers. Now what is the kind of a collectors that we add? And by the way, what is collector? Sometimes they might use the word collector, sometimes they might use the word frothing agent, or sometimes they will say foaming agent. All these words means only one thing: we are adding oil. And the kind of oil that we need to add are pine oils and fatty acids and xanthanes. Whereas we also require a froth stabilizers, which are substances like cresols and aniline. So once we add all these components, it's very obvious the sulfide particles will prefer to get wet by oil and the gangue particles will get wet by water. The next thing that we need to do is we need to use a rotating paddle and then churn this mixture. Now when you churn the mixture, oil has a tendency to form froth. So as a result, a froth is formed, but what does that froth contains? The froth contains the mineral particles, that is the sulfide particles, whereas the gangue particles are left in water. So what is the next thing that we can do is we can skim off that mineral or the skim of that oil or the froth particles. We can press it, clean it, and use it for the further recovery of the metal, whereas the gangue particles are left in the water and that can be thrown. So the same froth flotation in industry, it's carried out in this manner. And as I told you, this is precisely used only and only for sulfide ores. Now the question that arises is, what if there are two sulfide ores are present? If there are two sulfide ores and if you add oil, both the sulfide ores will get wet by oil. But I don't want that to happen. I want only one sulfide ore to get wet by oil so that they can come out, and I want the other sulfide ore to go as an impurity. So please remember students, if you have two sulfide ores and if you want only one sulfide ore to come out and if you want the other to go as an impurity, the answer is very simple. To such things we need to add something called as depressant, which will depress one of the sulfide ores. So now the next thing is, what is the principle? How does it really work? Let us see. Imagine if we have two sulfide ores, ore 1 and ore 2. To this, I'm going to add a depressant. Now, depressant are very common solutions like sodium cyanide and potassium cyanide. So now what will this depressant do is, this depressant will react with one of the sulfide ores and they will form a compound, or they will form a complex which is water soluble. Please remember, sulfide ores are insoluble in water, but this depressant reacts with that sulfide ores and they will convert them into a compound which are water soluble, and the other sulfide ore is left behind which is water insoluble. So they will come out in the form of a froth and the other one was left in the water. Let us take an example of this kind of a scenario where I have a mixture of lead sulfide and zinc sulfide. So I want only one sulfide ore to come out and the other one should go as an impurity. So during this condition I will add a depressant, and a very common depressant, as I said before, is sodium cyanide. Well, this sodium cyanide will react with one of the sulfide ores. In this case it will react with zinc and they will lead to a form a complex which is sodium tetracyanozincate. I repeat, it will form a coordination complex which is sodium tetracyanozincate, which is a water soluble compound, and the other ore, that is lead sulfide, is left behind, which will come with the oil. We can press it, clean it, and we can use it for the further recovery of the metal. So this is the practical example of the froth flotation. So we have done with three methods so far. So let us see some of the questions that can be asked based on froth flotation. The very first question is, the ores that are concentrated by froth flotation techniques are It's very simple. As I said, it can be preferentially used only for sulfide ores. So the right option is B. And the second question is, the froth flotation process is based upon. They're asking you the principle. As you know, it is based on the principle of preferential wettability of the sulfide ores by oil and the gangue particles by water. So the right option over here is option C. And the last question is, which of the following is used as a foaming or a frothing agent in froth flotation process? So the kind of oil that we need to use is a pine oil, right? So the right option is A.